Hello everybody, we're going to pick up where we left off in the last video, and that is working on our Python review exercises. I'm just going to make sure my screen is refreshed here. So we're working on this set of exercises here. We got through all the chapter 7 and 8 stuff. There was 4 exercises in the previous video, and now we're starting in the chapter 9 stuff, which we have 2 exercises in this chapter. I do have the Word document still up on the screen here. So we're going to work on these two, 9.5 and 9.6. The first one says implement the class sodacan with methods get surface area and get volume in the constructor supply the height and radius of the can. Okay, so this is an exercise. So like some of this is predicated on the fact that you've been kind of like reading that book and following their examples where they start to talk about these concepts. Chapter 9 in the Python class really starts to talk about objects and classes and how to add methods and stuff to those things and how to build basically objects and then utilize them in a program. So it's kind of a combination of things in tandem with the fact that we're doing a little bit of math here. In the Spider IDE, I'm going to go ahead and create a new file. And let's go ahead and save that right away. And let's call this exercise 9.5 soda can. Seems pretty good to me. All right, the next thing that we have to figure out is how we're going to actually do all the math and everything that's involved here. And really the math isn't that hard. There's some basic formulas that we can use to determine like surface area and volume of a cylinder. Basically, those are kind of givens. And in fact, if you wanted to go ahead and Google what those formulas are, I would recommend it. The point isn't really the math as much as it is the concepts. Now, we are going to be doing some math, and that math is going to require that we do some math libraries. So in other words, since we're working with radii and volumes, we need to pull in the pi libraries basically. So I'm going to start by just pasting, oops, not that, but this onto the program. So first we're going to get our math import in there. Let's start with that. From there, we're going to declare a sodacan class. So I'm just going to put in a directive here. And let's begin by defining it. And I do want to point out that there's kind of an approach here that is a convention that Python programmers hypothetically should follow. And the point of that is that you really document your programs well, so somebody's looking at something, we can tell what this class is doing. This is a pretty simple one, and really all that we're putting in here is the fact that it has a height and a radius, and off of that height and radius we can figure out the surface area and the volume of the can pretty quickly. But notice that the class sodacan, we just have a little indicator there that also indicates what parameters we will be passing in order to construct a can, and they're defined here in plain text, and that's just considered a courtesy. Now, of course, you don't have to do that, but it's considered a smart approach. All right, so let's go ahead and get a constructor in here. So we're just going to throw in a definition here, and notice the double underscore init double underscore, right? And that indicates that it's a constructor. Also notice that all of those methods that are inside of a class also have to refer to self. In a lot of other languages we call it this, but it's basically the same thing, this or self. That's just how we do it in Python. And then that's always got to be included. So no matter what method we have in there, that's just has to be present. And then we also set the height and the radius. Those are the parameters we just showed above. From there, we would set up a definition for some of the methods inside the class. So we would start by, just for example, trying to find a good spot to paste this here. by putting in a method for surface area. Notice how we are putting that together. First, we're just saying compute the surface areas of a can. We're indicating what this is going to return when it's done. So we're just stating it, and once again, to help people that are looking at our code understand what our classes do. Now, often when you build classes, keep this in mind, you're often building them so they can be reused. So documenting it really helps quite a bit for people that are using our stuff. And then it also is going to help you when you're building your own library of functions. Now, this is probably not one that you would build, but it's an example. All right, so that's our surface area. And then we're also going to set up a method here to do the same thing with the volume. And you can check the formulas if you wish, but I do want you to notice just the terminology here and how we're applying the stuff that we're passing in. So we're expecting that people are passing in a height and radius, then we're setting those to basically the properties or the parameters of the actual object that we're creating, and then we're just doing the math. So this is really the whole program right here. Not very complicated. It's really just to demonstrate how classes are constructed inside of Python. That's a little bit different. Like if you're used to Java programming or C# programming, it's a little bit different approaches, but the concepts really do work the same. It's just a matter of the terminology and the syntax. Let's go ahead and run this. Apparently it doesn't like what I'm doing here, so let's make sure that we're saved for sure. Oh, of course. Okay, so what I have going here is I have, what have I built? I've built the class, right? I built the class to actually get the program or the object built, but I don't have the code to actually execute anything. Correct? So that would be the next aspect. And I apologize that I just plain forgot, because when you're in the stream of teaching a chapter, you're always thinking about all the stuff that you're being shown along the way. But this is just the class file. So what we really need to do is we need to basically create a program that tests the class, so that instantiates it and does an example of it actually working. So we're going to create one more new file here, and let's call it demo, and actually it would probably be smart to put x95, and then I'm just going to say demo soda can. It doesn't really matter, I guess, functionally what it is, but it's just to show that we can work. Now, since we are going to be using a class that we built ourselves, we do need to actually pull that in, and we use this from statement to import it. And notice the syntax for this. So we are and see, this might be a little bit problematic, because last time I did this I called things by different names. So I'm just going to give you an example here. Last time I called it sodacan and demo sodacan, so it might be smart maybe if I actually do a save as on this. In fact, let's do that, and I'm just going to double check what I named it last time, just so that everything works. So last time I just called it sodacan, all lowercase, so let's do that. And was that there was an underscore in there, so let's just type it from scratch. Soda can, all lowercase, excuse me. And then the other one I just called demo soda can. Well, I guess that doesn't matter what this one is called. But now that I've got the demo thing, it does indicate which file I'm pulling it from, and then what I'm actually importing. So I'm pulling from this particular file, and I'm importing this particular class. Now I can use that class in my program like I use any class in any program. So the first thing we're going to do is we're going to basically construct a couple of cans from the class. So that's really simple to do. Knowing that we have access to this class, we know that we can pass it two parameters, height and radius. It just says so right here. And so we just call sodacan, and we send a height and a radius. All right. Next thing that we're going to do is we're going to ask the class or the objects that we've just created. Now remember, whenever you instantiate an object, it not only constructs it with its parameters, but it also carries with it these built-in methods. So I have methods where I can do stuff with that object once it's created. And in this case, we're just going to do it like this. I'm going to create two variables to hold the return values. And we're saying with can1, get the surface area, and get the volume, and it just triggers those methods inside there, does the math with the parameters that we pass to it, which you can see above. And then, of course, we can print it out and make sure that our work is correct. All right. And then, heck, since we're testing it once, you better test it twice. I always tell people, don't test it just once. Do a couple of things. So let's create that second can and do it again. Now, if you were persnickety about this, you would, of course, run the math in a traditional method to make sure that it's all working correctly before you call it done. So let's go ahead and save this. Let's hit the run button, and then you can see, and we're just going to assume, whatever units of measure you're using or whatever, that these are the numbers that are correct. And I have, written this program before and verified the values, so the formulas are correct, and the output is correct. If you look at the class file once again, so this is the entirety of the class. This is for the code copiers there. And then this is the entirety of the demo program to show that it actually worked. All right, let's move on to the next exercise. I'll get that Word document up here, and that next exercise is this. It says, implement a class car with the following properties. A car has certain fuel efficiency, measured in miles per gallon, and a certain amount of fuel in the gas tank. The efficiency is specified in the constructor, and the initial fuel level is 0. Supply a method drive that simulates driving the car for a certain distance, reducing the fuel level in the gas tank, and methods get gas level to return the current fuel level and add gas to take up. Sample usage. Okay, so they show you how you might instantiate it, add gas to it, drive it, and all those things. Let's start by building the class car. So I'm going to just create a new file. I know I've been doing like exercise number, but I learned from my sodacan one, since I'm borrowing examples, that it's actually better for a file that contains a class to have a simpler name. So I'm just going to save this one as car, C-A-R, car. All right. All right. And then I'm just going to follow the pattern that I've used here before. And, I'm going to get rid of all this junk up here at the top and these quotes, since we're not really using them. But it just says this module defines the car class, right? A car that tracks its fuel consumption as it is driven. So we have the basic definition here. And then from there, we are going to put in the constructor. So the constructor is going to start like this. And you can see it constructs a new car with a given fuel efficiency, and the parameter that we're passing in is how many miles per gallon you get out of your car. From there, we're going to add a method to add gas to the tank. So we'll just have a method that we'll say add gas, and then it will add however much gas in gallons you want to throw at it. Then, of course, since we're trying to get this all simulated correctly here, we have to make sure that we put in something to indicate how the car is being driven and utilizing the fuel. So we have to put in a distance, and then it will subtract that from, the amount. So basically it's going to calculate the fuel efficiency. So we're taking some of this math for granted here. If I was in a regular programming class, I'd go through all the calculations, but I assume you guys can figure out miles per gallon. It's pretty simple. All right. And then finally, we also have to have a way to see how much gas we currently have, basically the fuel gauge. So we're going to get the gas level, and we'll see how much fuel we have left. So this defines our car class. Constructor, the adding gas, how much distance we've driven, and current indicator of that. All right. Now, we could try to run this. Of course, it's not going to do anything because it doesn't have an executable component. But I'm seeing that I have no flags or underlines or highlights or anything, so my syntax all looks good. Now we need to create a demo program to try this out. Fortunately, that's not too hard to do. As we just saw with the sodacan thing, it's more a matter of kind of principle than anything else. Let's create a new file and do a save as immediately. And let's just call it exercise 9.6 demo car. All right. Of course, since we are going to be using our class that's external, we are going to import car from the file. And pretty simple little thing, but you have to put that in to show that you're tying them together. Now, what I think is fascinating, in some languages you don't functionally need to do this. And a lot of people don't know this. Like in Java, if you have your class files are in the same folder, you don't have to import them; they just work. However, if you took your class files and built them into a library or an archive or something like that, and you have to import them in there from a different spot, then you do have to put those in Java. Here in Python, it's just always considered good practice to do that. Put it in the same folder and import it. All right. So I'm going to basically use these examples that I put together before, and I'm going to change this number. So we're saying that this car's got 50 mpg. I'm going to put in maybe like a more realistic number for a lot of people, which is maybe like 25 or something like that for like an average modern car. 20-gallon tank is not unusual. Drive 100 miles and get your gas level. Now, what's interesting is, and I used this as an example last time, is my crappy little Volkswagen car that I've been driving around for quite a long time with a gazillion miles on it. It's over 320,000 miles now. But the reason I drive it, and people are like, why do you drive that car? It's like, well, I average between city and highway about 46 mpg. It's diesel, and I just want to show like a difference in terms of how these operate. So I'm instantiating two cars with different gas mileages. We start by adding gas because the tank is empty. My car only holds 13 gallons. Most cars hold about 18 to 20. And then we're going to drive 100 miles and we're going to get the gas level. All right, and this is all it takes to test it. And a couple examples is always a smart thing. So let's save this and then hit the run button. And I'm trying to figure out what the heck this means. It looks like it's still running. Okay. I thought that it was trying to run the sodacan class. And then we're trying to get the gas level. This does not seem to be right. So here's what I'm going to do. I'm going to actually, and I don't know if you guys have ever run into these issues, and this can happen when you're working with more complicated programs, and we haven't really done that much. So what I'm going to choose to do here is I'm actually going to restart my console here, and it actually has its own little kernel or whatever. So I'm just going to restart it just to make sure all the buffers are cleared and nothing's stuck in memory. So let's just give it a second to reboot there. Then we're going to run our program here, and hopefully everything will be wonderful. All right. I'm going to go ahead and run this. And my impression is that this isn't... Aha! Okay, so I see what's going on here. So when I'm printing out the hybrid for both, and really I should be printing out... There we go. All right, so now we run it, we should get different numbers. All right. So what it's saying is that at 25 miles per gallon, and a person drives 100 miles, right? It doesn't take a genius to figure out that you're going to use 4 gallons of fuel. So if you started with 20 gallons, you have 16 left. Mine, on the other hand here, I started with 13 gallons, and I went 100 miles. And so really, maybe a more helpful output would be how many actual miles or how many actual gallons we used in the process of driving that distance. Now, if you do the math on this, of course, if I subtract 10.82 from 13, you can see that I did it with a little over 2 gallons, whereas the other car did it with 4 gallons. And if you start like putting in, changing the numbers here, so for example, and you can pull out a calculator here, and I think this is where it gets a little interesting, is if I have a car that's got a 20-gallon capacity and I'm going 25 miles per gallon on average, I'm only going to get 500 miles out of a 20-gallon tank. And if you compare the why as to why I drive this like junky little car, and you multiply that 46 times the 13 gallons, you can see I get 600 miles on 13 gallons of fuel. And depending on how you drive, you can get a little more or less, but that's my average calculated MPG between city and highway driving. When I get on the highway and it's nothing but open road, it can actually be significantly higher. So I think this is really kind of an interesting little program. Of course, you could add a lot to it, a lot of different outputs and stuff, but that's not really the point. The point is to instantiate a class and to get it to operate and do a little bit of math and whatever and get some output. All right, folks, that really ends what we're doing here in this exercise. I'll get this posted as soon as possible. And thank you for following along. Take care.